Assalamualaikum. My name is Muhammad Faris. Okay, today I want to present pulse code modulation (PCM). The example below show how to use MATLAB software to apply the pulse code modulation (PCM) technique. Okay, our first question is what is the frequency of the analog signal that has been used in the example 1? Okay, first, the example 1 is already given. Okay, I just copy this coding and paste in MATLAB. Okay, and then enter. Okay, and we get this graph. First, we get this graph: square signal, encode signal, decode signal, and analog signal, sample signal. Okay, the question is what is the frequency of the analog signal that has been used in the example 1? Okay, first we take all the graph and paste in the Microsoft Word, and this is the answer. The formula of frequency is 1/t. Okay, how to get this frequency? Okay, from the MATLAB, how to get the frequency, and we put this plot one cycle. The one cycle is we get 126. Okay, half cycle we get 26 for half cycle. Okay, and from one cycle we get 126. Okay, and we just substitute into the formula 1/100, and we get the frequency is 0.01 Hertz. Okay, thank you. Question 2. For question 2, generate a 2 kHz sinusoid with a peak voltage of 2 volt plus minus 1 volt, and generate a quantized signal when n equal 8 and n equal 16 levels. Calculate signal to quantization noise ratio, SQ&R. Okay, the formula is already given. Okay, this is for signal to quantization noise ratio. The formula is V/SET2 divided by 2 square and minus 1 multiply SET12 equal V/SET2 multiply 2 square and minus 1 multiply SET12 over V equal 2n SET3/2. Okay, this answer I already substitute from this formula. Okay, for peak to peak voltage already given 2 volt. Okay, this 2 I just substitute into V over SET2 and over 2 square n minus 1. N is 8. 8 minus 1 is 7. 2 square 7 multiply SET12. and the answer is 1.4142 divide by 443.405, and I get the answer is 3.189 m for n egg. And for N16, I just substitute the answer is the voltage peak to peak is already given. Just I substitute 2 divide by set 2 divide 2 square 15. Why 15? Because n is 16. N is 16. 2 square n minus 1. 16 minus 1 is 15. And multiply set 12. And the answer is 1.4142 divide by 113.511 K, and I get the answer is 0.1245 micro. And for SQNR, signal to quantization noise ratio, 4 dB. 4 dB is the formula is 20 log 10 2 square n multiply set 3 over 2 and equal 20 n log 10 2 plus log 10 set 3 over 2 and equal 6.02 n plus 1.7609, and I just substitute the answer is 20 log 2 square egg is n is already given egg, and multiply by set 3 over 2, and I get the answer 49.925 dB. And for N16 is the same for N8. I just substitute 20 log 2 square 16 n multiply by set 3 over 2. This 3 over 2, and the answer is 98.091 dB. Okay, first question 3 is use the MATLAB Simulink for the question 1 and question 2. Okay, first we use MATLAB Simulink. This is the MATLAB Simulink. We use signal generator, pulse generator, product, encoder, integer to bit converter, bit to integer converter, decoder, sample and hold, analog filter design. Okay, this is scope. Okay, first we set the signal generator is amplitude is 1, the frequency is 100. The pulse generator we set amplitude 1, the period second 1 divided by 1000. The pulse width is 50. This we put the number of input is 2. The encoder peak is 1, bit is 3. Integer to bit converter is 3. Bit to integer converter also 3. The decoder we set the peak is 1, bit is 3. And the sample and hold initial condition is 0. Analog filter design, the filter order we use 2. The passband edge frequency is 2 times pi times 100. And this also same the pulse generator this. And we take the oscilloscope and we connect the probe to the scope, and B we connect to the scope, and C also we connect to the scope, and this we also connect to the scope or oscilloscope, and the output we also connect to the scope, and we get the result this graph. Okay, first this graph is analog signal. This is sample signal, this is encode signal, and this is the full graph that combine the analog signal and square signal. Okay, as we can see, the first question that I get the result is the same. Analog signal, and this sample signal, encode signal, decode signal, and this is the square signal. Okay, so we get this graph is the same. Okay, for example 2, question 3. Okay, use the MATLAB Simulink for the question 1 and question 2. Okay, question 2, we take the coding from example 2. Okay, this coding. Okay, this coding we paste all, and we paste into MATLAB. Okay, and then enter. Okay, and we get this result. Two graph. Okay, analog signal. This graph combine full graph analog signal until square signal. Okay, and we paste in Microsoft Word. Okay, from Simulink, MATLAB Simulink, same like this, and we use this all component, and we get also same like MATLAB this graph. Okay, so that's all for all question that I have answered. Thank you.